So we discussed about the theoretical concepts of Z-score and how it can be used to determine the probability of a particular value in a population, or how can it be used to determine an outlier. So now let's go ahead and implement this using a particular data set and understand and find the outliers in that particular data set. So we'll be discussing two methods here. One is using Z-score and the second one using quantiles. So first method here we'll be using Z-score. So let's first import the pandas and numpy package, and then I have used the placement data set, which is basically about the placement record of students in a B school. So I have created a data frame and imported the placement.csv file into it. And just for you guys to understand how the dataset looks like, I have displayed the first 5 records of the dataset. So this dataset is basically a mixture of categorical and numerical columns. So as you could see, these are few categorical columns, and then we have numerical columns as well. So this is what we'll be using and we'll actually be selecting one of the columns from this data frame, and we'll be finding out the outliers in it using z-score. So before that, few things, few housekeeping things that we need to do is we need to determine whether there is any NA values or not applicable values in the column, and then for our use case, we are deleting or dropping those not applicable columns, but there will be some kind of scenarios where we may need to keep those not applicable columns. But for now, we will not be using those. We'll just be dropping those. So first, let's see what are the NA values that are present in a column. So if you see, we have 67 values in which there is no salary attached. So we'll go ahead and we will drop these particular values from the salary column. So guys, one thing, this data set I have downloaded from Kaggle. I'll provide the link for this in my post as well, so that you can go ahead and you can download the data set, and then you can implement this using the code that I am describing here, or you can also play around with the data set on your own. So now after we drop the not applicable values from the salary column, I will go ahead. I have created a function which basically defines what the z-score is. So this is the formula for the z-score. I have basically created a function to implement this formula. So for that, couple of things that we need to understand, that we need to keep in mind. So as we discussed in the theoretical part, a z-score is within 3 standard deviations from the mean, right? So for that, I have taken a max deviation of 3, and then I have created a list for outliers. So anything which falls outside this 3 standard deviation will be appended to this outlier list. So then np.mean I'm using to determine the mean of the data. np.std I'm using to determine the standard deviation. And then I'm looping through the whole column using a for loop, and then I'm implementing the z-score formula for each values in that particular column. So after that, if I'm determining the absolute value for the z-score that I got, and comparing whether it's greater than or whether it's not greater than maximum standard deviation. If it is greater than maximum deviation, which is 3, then I'm appending it to the outliers list and then returning the list. So this is what the function does. Let's go ahead and pass the salary column to this function and see what are the possible outliers that we get. So if you see, we got an outlier. We got 3 outliers, in fact. One was 940,000, 9,40,000, and then the other was 690,000, and then the third one was 650,000. The first one is 940,000. Sorry. So this is how I have tried to, like, I have shown to determine the outliers using a z-score. And then we can also use the quantiles to determine the outliers of a particular data set. So before that, let's see what are the possible examples, and also understand what interquartile range is, and then few other things around it. So suppose I'm taking an example where the normal monthly salary of a person is $5,000 per month, and which this is a normal this can be seen as a normal thing, right? And then suppose he gets a salary of $10,000 a particular month, which doesn't seem right, or which can be a spike in the whole normal distribution. So what this means is this can be an outlier. However, we can think of it as a bonus that he got at the end of an year or stuff like that. But still, if you think of it as a data, then it is a spike in the whole distribution, and it can be considered as an outlier. And the second example is in case of credit card transactions, right? So if we think of it as this, a person has a credit card transaction, a range of 150 to 300 or $200 all the time. But suppose there was one transaction which happened, and that was more than, or which was like around $2,000. So this can be considered a potential fraudulent transaction. So this is an outlier. So, but the thing that we need to keep in mind here is some outliers are used to determine some important conclusions. So all the times we can't ignore, or we can't just strike out the outliers. In some cases, it can be used to conclude some important things. So in this case, in case of fraudulent credit card transaction, the outlier can be used to conclude or determine whether a particular transaction was fraudulent or not, which is very important. So this was about few examples, and then let's go ahead and see what quantiles means. So this is basically this measures the segments of a data. So how a data is divided, this can be determined using quantiles. So this includes percentiles, quantiles, and so on. And then let's understand what percentile is. So percentile is defined as the percentage of data that is present below the value of the original value. For example, suppose a student scores a percentile of maybe 90 in or 95 in an exam. So what that means is there are 90 people or 90 students who are below him. That's what percentile means. Um, and then what's then let's understand decile. Decile is defined as the 10th percentile, which means the data point that are present below decile is 10% of the whole data set. And then quartile, as the name suggests, is defined as 1/4 of the data, which is the 25th percentile. And this basically can be categorized into three different quartiles, which is the first quartile, second quartile, and the third quartile. The first quartile is the 25th or 25% of the data. Second quartile is 50% of the data, which is also called the mean. And then the third quartile is 75% of the data. Okay. And then finally we have interquartile range. So this concept is pretty important, guys. Interquartile range is basically defined as the difference between the third quartile and the first quartile. We'll understand more about this and see how it is used to determine the outliers going forward. So for now, these are the few concepts that we need to keep in mind. So so in order to determine what an outlier is, we need to know that anything which is lying outside the boundary of the first and third quartile can be considered as an outlier. So suppose and two more things. One is upper bound and one is lower bound. So we'll discuss about upper bound and lower bound as well going forward. But for now, we need to know that upper bound is basically the third quartile plus the product of 1.5 times the IQR, and the lower quartile is the first quartile minus 1.5 times the IQR. So let's take an example to understand and sum up all the concepts of quantiles that we discussed so far. So suppose, guys, we have a distribution of these numbers, and we want to find what are the outliers that are present in this number, right? So for that, we need to follow a few basic steps. The first step that we need to follow is we need to rearrange this in these numbers in ascending order, and then we need to calculate the median for this. And once we have the median, we'll split this into two halves. The first half will be the first half will have the values which is less than the median, and the second half will have the all the values which is greater than the median. And then after that we will determine the Q1, which is the first quartile, which is basically the median of the first half, and then Q3, which is the median of the second half. And one thing I need to tell you here, guys, the second quartile that I said here is actually the median. I by mistake I said mean, but it's actually the median, which is also the 50th percentile, or also called the fifth decile. So now after we found the Q3, which is the third quartile, let's determine the interquartile range, which is basically Q3 minus Q1. So in our case, it will be 72 minus 70, which is 2. And then after that, we will find the upper bound and lower bound. So anything which is outside the upper bound and lower bound will be considered as an outlier. So the upper bound will be Q3 plus 1.5 times IQR, which is 75, and the lower bound will be Q1 minus 1.5 times IQR, which is 67. So anything outside these two values will be considered as an outlier. So in our example, we have two values, 90 and 320. So clearly these two values are outside 75 and 67. So these are our outliers. So this was a basic example to determine the outliers using interquartile range. Let's try to implement this in our data set and see what are the outliers that we get. So first things first, we need to understand. We need to find the Q1 and Q3, which is the first quartile and the third quartile. For that, I am using this numpy function, which is np.percentile, and then and the arguments to it is the salary column, and the second argument is the 25 and 75 percentile list. And then the value, the first and third quartile that we get here is 240,000 and 300,000. And from that we will be calculating the interquartile range, which is the difference of third quartile and the first quartile, and the value is 60,000. And then after that we'll be calculating the lower and upper bound. So as I discussed above, the lower bound is Q1 minus the product 1.5 times the interquartile range, and the upper bound is Q3 plus 1.5 times the interquartile range. So the value for lower and upper bound that we get here is 150,000 and 300,000 respectively. So now if anything, so these are the upper and lower bounds. So anything which lies outside this boundary will be considered as an outlier. So guys, let's go ahead and plot this out in a box plot and see what are the values which are lying outside this boundary, right? So I'm using this to plot out the box plot, passing the salary column to it. And if you see here, these are the values. Obviously, these are greater than 390,000. So clearly this is above the upper bound. So this is the outliers that we have for this particular column. So this was a explanation about how interquartile range can be used to determine outliers, and how it can be implemented in terms of code. So thank you guys. This was a session about determining outliers using Z-score and interquartile range. We'll discuss more about other topics as well going forward. Thank you.